that could happen on a mine site. They could stop everyone from working and possibly send everyone home early.
Injury or fatality?
Yes. A fatality or severe injury or multiple fatalities, multiple injuries. It'll definitely shut the mine site down. Now we don't want that. I'm not going to make money. Just think about the last time you did a Take 5 or JCA. If you have one. Have you ever done one? No. How do you decide if the risks of the task you're doing are acceptable or unacceptable?
Risk assessment.
Well, by the end of today, you'll be able to identify hazards and use a hierarchy of controls to mitigate the risk of harm. First, we'll look at some hazard identifications. Then move into risk assessment, so we'll assess those hazards. And then finally, implement control measures. We'll see what control measures we can put in place. And then reassess the risk to find out whether those control measures are effective. Now, mastering these skills are not just about compliance. It's about making sure you and your teammates stay safe every single shift. So we'll start off with some hazards. Now, the hazards can be broken down into these categories from the energy source that's used to create the hazard. Electrical power from mains, batteries, etc. Capacitors. Mechanical engine, energy and moving parts, or items under tension, a spring or piece of rope. If it breaks, hoses, springs, flywheels, rotating blades, like the fan. Hydraulic energy from presses, hydraulic presses, machinery that use hydraulics, generally hydraulic power systems all over the place. Pneumatic energy, stuff could be powered using air, bike pump, tyres, air pressure in them. Gravitational is the potential energy of a suspended or elevated object that could fall, e.g. raised hoist. Something can fall from a wall or a shelf. You could fall. Thermal, hot, cold. It's either too hot or too cold. Chemical, generally any type of chemicals that could cause a reaction, often resulting in a fire explosion or toxic leaks. Radiation, energy from electromagnetic sources like lasers, X-rays, or UV from the sun, for example. Biological, organic substances or agents derived from living organisms, viruses, bacteria, fungus, parasites. Now, I've got this hazard sheet in front of you. If you could if you just go through each picture, identify the hazard, and just a brief description of the hazard and the energy source. So I'll help you. The first one's pretty obvious. Ooh.
Wouldn't this one mean that the baby's being given access to a bunch of chemicals?
Well, yes.
So would
This
chemical?
that's the one I see first, because a baby obviously can get hurt by the door slamming or whatever, but the chemicals could kill.
Yeah.
So I would,
Chemical?
yeah, I would put chemicals.
Would this be him getting burnt by the thing, by the sparks?
Yeah, definitely. He could get burnt. I have actually got burnt from pretty much doing the same thing. If you're not wearing fire resistant clothing or something, they will burn, and it's burnt through my shirts. Sometimes I don't even know it's actually burning until I feel it.
Yeah.
So yeah, definitely. So what kind of energy source would that be? And the hazard obviously getting burnt.
Would this be biological?
Yeah, what's the hazard you see there?
Germs being spread.
Yeah, germs.
Then this one would be mechanical.
Yes, definitely mechanical. If that gear, while it's got his hand on it, was to start moving and turning, his hands will get crushed.
He could even get pulled into it.
He could get pulled into it as well. Excellent. Finished?
Yep.
Yes, so we'll go back to the hazards, and these are your main types of hazards. You can probably come up with a couple more, but they're the main ones, especially working in mine site area. They're the main ones you'll come across. Electrical, mechanical, hydraulic, pneumatic, gravitational, thermal, chemical, radiation, and biological. Now that we know the hazard, we need to assess the risks. So assessing risk is a systematic process identifying potential hazards. We've identified the potential hazard and evaluating the likelihood and severity of harm they could cause. So we move into severity and likelihood. So when it comes to the likelihood of something happening, or the severity of something happening, negligible means basically little to no harm, like a small scratch or a cut that doesn't even bleed. Something that's pretty negligible or no harm at all. So if this piece of paper dropped on my hand, I'm not going to get any damage there. I could get a paper cut, pretty much little to no harm. So me handling this paper is pretty much harmless. Minor, a cut which it's bleeding, and you'll need a band-aid over it as a minimum. No lasting consequences. You might get a bruise. You'll be there for a little bit, but it'll generally disappear after a few days. damage, minor damage, when we come to severity and assessing risk, we're also looking at the environment and damage to equipment. So it's not just injuries, it's also a damage to equipment and the environment. So minor, like a paint chip or dent that doesn't require, like you can still drive the car. A small spill on the ground where I can just get a rag and wipe it up. Moderate is major damage or major injury to equipment, environment, or major injury requiring professional medical treatment or brief hospitalisation, like a broken bone or deep cut requiring stitches. So where you'll need a medical professional to fix you up. Broken bones obviously, and stitches, someone's going to have to stitch that big deep cut. That is moderate damage, and moderate damage requires extensive repair. Say if you hit the car and the bumper fell off, you obviously need to put the bumper back on. Environmental damage requiring extensive cleanup, removal of contaminated soil. So if you have a big spill and you can't just wipe it off the ground, you've got to actually dig up that ground to get rid of the contaminated soil. Significant because of the high level of impact. This often requires serious or life-altering injuries, major financial loss, long-term service outages, damage to a brand's reputation, serious impact to the environment which may be reversible but requires extensive effort and high costs. So a major oil spill, so in the sea and so forth, is obviously significant, but it can eventually be cleaned up. After a while, eventually be cleaned up, that environment will get back to where it was. High level injury, going blind, going deaf, losing an arm, being paraplegic. You're not dead, but sometimes you might want to be dead, which goes into severe, which you are dead. Environment, something like just Chernobyl nuclear disaster. That Chernobyl area will never ever be the same again. It may take hundreds of years for that to actually eventually fit, and it's probably never going to be the same, ever. If your equipment's just totally destroyed and needs full replacing, or if a factory burnt down, that means obviously replace the whole thing. That's obviously severe. Then we move on to likelihood. It's very unlikely, little to no chance of happening, under 10%. So it's pretty much not going to happen. Unlikely, it's more likely not to occur than to occur, 11 to 40% chance. So it may happen, but once again, it's not likely to happen. Possible, it might occur occasionally, perhaps once every 3.5 years. So it may happen, but not like it's going to happen. It's almost 50-50 that it might happen. Likely it is more than 60% chance of happening. So it's more likely it's going to happen than it's not. And very likely it's almost certain to occur. Almost certain, not 100%, but almost certain. And if we look at the risk matrix, I'll put it in front of you, it'll give you the severity and the likelihood in each column or row. Now, what I'll get you to do is go back to your hazards and each of those pictures, just quickly assess that hazard and see what you come up with. If you've got a severity factor of significant and it's very likely to happen, then the risk is going to be assessed as high. Anything in the red is a no-go. So if we assess a task or assess a situation that puts us in the high category, then we generally do not do it. Don't touch it with a 10-foot pole. In Port Longyear, most companies, they'll actually tell you where each one of these sits and what to do in those situations. So in Port Longyear, we don't do anything in the red. If it's a med high, then we've got to get major management approval and probably engineering controls to put in place to lower that from med high. Medium, we need management approval and supervisor approval to carry on the task. Low, medium, we can do the task as long as all the controls that we put in place are going to be there and sufficient. And obviously low, carry on and do the task with caution. So if you can just go through the hazards that you've identified and just put down a rating as you see fit. Excellent. Excellent. So what have you done there? Mid high, medium, mid high, yep. Medium high. Nothing in the red, which is good. But a lot of mid highs.
No, these two are in red. This one.
Okay.
And this one as well.
Okay. Oh, significant. So the baby could die.
Yeah.
That's true.
So would that be
So
severe?
that would be severe.
And then this guy could get pulled in, and so that could be
Yeah.
severe as well, because he has risk of dying.
If we look at the description there, severe, he could die actually, yes. There is a possibility he could die.
Yeah.
If he gets pulled into that machinery. So yes, probably, yeah. I mean, this is how you feel about it.
Yeah.
And especially if you're going to be the one doing the jobs, if you rate a hazard as high or the risk as high, that's how you see it, and we run with that. Now obviously the next step is to get that from a high down to a low medium so that we can do the task. Some of them actually end up being medium maybe. We'll see. So obviously we've assessed the risk. Now we've got to implement controls. Effective control implementation ensures that safeguards are not only well designed but also operate consistently to manage identified risks. When selecting specific control measures, we use a hierarchy of controls to prioritise the most reliable methods. So if we've got the hierarchy of controls here. Now, each control method will fall into some sort of category, one of these. Elimination is completely remove the hazard. Substitution and replace the dangerous task or substance with a safer alternative. Isolation, place a physical barrier between the hazard and worker, so the hazard has no chance of hurting the worker. Engineering, redesign equipment, tools or workspaces. Exposure to hazardous substance or machinery parts. Administrative, change the way people work, establish safe operating procedures. And PPE, provide protective gear. That's the last line of defence. So obviously with elimination, we can completely get rid of it. It's no longer there. Substitution, so we use a very hazardous chemical for cleaning. Acid, we get rid of the acid, we just use spray and wipe. That obviously lowers the risk or gets rid of the hazard, but still replaces it with something else. Isolation, so if that fan, if I was to work around it and there's a chance of me getting cut by the fan itself, I can turn the fan off. And that's isolating it. Engineering, back with the fan again, the guard around it stops me, so that fan can be going, but my fingers can't go in there. Way too small. Administrators safe, they're basically signs or procedures that you have to follow. You must do this before you can do that, or do not do this. And in procedures, they'll generally highlight something, do not do this. Under any circumstances, do not do this. PPE, it's basically putting up a towel and saying, I can't stop you from being exposed to the hazard to do your task. I can't stop you from being exposed to that hazard, but we can put protective clothing around you to minimise the impact that that exposure is going to be, to minimise or eliminate the impact. So if I'm in a dusty room, I've got to put a full respirator on, then I'm going to stop the dust. The PPE is going to stop the dust from going into my lungs or smoke. So what I'd like you to do now is to come up with some controls for each of those hazards. See where you think it sits in the hierarchy of controls, control measure that you come up with, and then put a residual risk. So reassess it with those controls in place. Okay.
Would this be engineering?
Yes, yeah, it would be. If you're going to get that fixed, that's a whole engineering job, that.
Yeah.
And you need to be certified. There has to be a proper electrician to do that.
Yeah. For this one, I put baby lock or put the chemicals in a higher coloured so it won't have access to it.
That's two there, really. You could put the chemicals somewhere else.
Yeah.
That's elimination.
Yeah.
And then put some baby locks on. That would be engineering. So if you did it in elimination,
Yeah.
and you go reassess it, it's pretty much low
Yeah. So.
because it's gone.
Oh, you see this one.
Yeah. It's anything like elimination, pretty much
It's really
takes anything down to here
Yeah.
instantly.
Would this one be like wearing more PPE, like an apron?
Yes, you can get a spark apron,
Yeah.
a hot work apron. Which is fire resistant, can handle the sparks hitting it.
Yeah.
If you've got sparks kicking at you, even though you've got the apron on, yeah, you won't feel the sparks, you won't get burnt.
Yeah.
But apron actually still gets hot.
Yeah.
Yeah, it still gets a little bit hot. Especially if you're doing it for a long time.
Maybe.
That's
really
going to stop them from getting burnt.
Yeah.
Yeah.
So it would be PPE.
Yes.
It would be probably mine now since he's not getting burnt anymore. It'll be probably low.
Yeah. Probably more low medium because
There's still that kind of risk. He could wear a mask.
Yep.
So that would be PPE. Change it to low mid. This one. Should he be holding it like that?
I probably shouldn't be.
So would he need some more safety courses to try and prevent him from doing so?
Yeah, I would look at putting a guard around there so you can't do that. But the machinery's there for a purpose, so it's got to work, it's got to move. But we don't want him putting his hand there or put any part of his body on there, so safety. Guarding, safety guarding.
And then would that be isolation?
Probably. Oh no, that'd be engineering because you've got to engineer the guard on.
Yeah.
Yep. See, redesign equipment, tools.
I'd probably say medium to low med.
Yeah, probably low med.
Yeah.
Excellent. So now you've done basically 1, 2, 3, 4, 5 risk assessments. They're only small ones, but you've just done what, 5 take 5s or take, say in the business. Anyway, so yes, today we've successfully identified hazards, applied a hierarchy of controls, and to mitigate them. You did a fantastic job. I have complete confidence in your ability to keep a safe workplace. Now, the next session we'll build on these skills by looking at how to conduct more formal, broad-scale risk assessments, big JHCAs, etc. Anyway, you've done a fantastic job and good work. Well done. I'll just get you to fill out evaluation form on the session. Please. Be much appreciated. Other than that, thank you.